Okay. Hi, everyone. Welcome.
Welcome to another video. We're going to talk about all about the body again. And you might be able to guess what body system we're going to be talking about today.
We're talking about the skin, aren't we?
We're talking about not the skin.
Okay.
Mort, do you know what we're going to be talking about? Mort says he does. So we're going to be talking about, first we're going to be talking about the skeletal system. So these are the bones that make up the body. And so you can find a lot of this information in this booklet, All About the Body by Heron Books. This is available free for you. You can download it and read it and enjoy it and learn about the body. So I'm going to put this down. And first I'm going to ask some questions. Actually, first I wanted to answer a question that someone asked yesterday in our video that we didn't get a chance to answer. And that was, someone wanted to know, we were talking about blood and the circulatory system and this sort of thing yesterday. And someone wanted to know where the different parts of the blood, we mentioned that red blood cells are formed in the bones, bone marrow, the inside of the bone, the pinky kind of stuff.
Inside of there.
Inside there, right. So you can break open a chicken leg and you could see that pink spongy stuff. And that's where red blood cells are made. But white blood cells, which are used to fight diseases, and platelets, which are used to seal cuts in the blood tubes, arteries or veins or capillaries, are also made in the good old bone marrow. So, do we get any answers or response? Oh, if you have a question or you want to chime in, use the Q&A box. So the first question is, why do we have a skeletal system? Why bother?
Yeah, put your answers of that to that question into the Q&A, the question and answer box below, and I'll read those out as they come in. I think we have a skeletal system because it's important.
Okay.
Yeah, I'm going to start with that.
I was hoping for something a little more definitive, a little more precise.
Yes, well, I'm counting on our viewers here to help answer that question. We have some much better answers than mine coming in already.
Okay.
Okay. Either Denali or Mackenzie saying if we didn't, then we would just be a blob.
Yep. A blob, right.
Isis
like
says,
Jello.
Yep. So we're not just jelly.
Exactly.
Yep. Nate says to keep us like we are. I like that.
Yeah.
That's great. Sarah says because otherwise you would just be a blob, unable to have much of a form. Mm-hmm.
Yeah.
Yeah.
Okay. Gives you shape, gives your body shape. Anything else you could think of? Any other reason to have skeletons, to have a skeletal system, bones, and that sort of thing?
Yeah. Chris says it allows us to move.
Yes, it does.
Yeah.
We have the muscles which attach to the bones, and that helps us move.
Yeah. Gayatri says bone keeps us strong. And Coco says to give us strength.
Yes.
Oliver says because then you can stand and actually walk around. Yep.
Good.
See,
good
I knew we would get better answers than mine from all of you. Thank you.
Okay. Well, there's another reason, an important reason that I haven't seen yet or heard yet. Maybe somebody sent it in.
All right.
Anything else? No?
We have a lot of, if I don't call out your answer, I apologize. There's a lot coming in. I'll do my best to keep up with all of them.
Okay.
Yeah.
Well, you have all of these parts of your body right in here. Right in here.
I think Ahmed just sent the answer you're looking for, maybe to keep our organs protected.
To keep our organs protected. Exactly right. So we have the heart and the lungs and the liver and all of these things. And these are very soft. You wouldn't want to fall down and squish your heart or lungs or liver or so.
Right.
This system of bones can protect these things. And also the old noggin up here, you have a series of bones which protect the brain. Now, how many bones do you think you have in your body? How many bones do you think you
Ooh, good. As you're putting your answers to that in here, I'm going to read a few more responses to that last question.
have? Okay.
Shauna says, as to why do we have bones?
Yes.
So that you can have blood cells that form in the bone marrow.
Exactly right. That's exactly right. You need to have the bones because that's where your blood, parts of your blood are made.
There you go. Milo said, yep. Milo said they make red blood cells. Cleo says it protects our lungs.
Yeah.
Katya says protects our organs. You guys are good.
Okay.
Yep. All right. All right, let me catch up here. All right, so Holly says 206. Kaden says lots. You're not wrong. Lorna says 210. Let's see. The Reeves family says 169. Aubrey says 162. Let's see. Cyrus says either 100 or 100. Let's see. Nate says 206 to 300. Oh, giving us a range. I like that.
You know, that 206 to 300 is the correct answer.
Okay.
Because you were right when you said 206, because adults have 206 bones in their body. But when we're babies, we have up to 300 bones in our body. Where did those other bones go?
I'm guessing we're not going to just put them into storage, save them for later. They probably fuse together.
They fuse together. That's right. So a good example of that is the skull. Could you bring up that photo we have of the skull?
Yes.
So you'll see.
We have so many answers. Thank you, everyone. There's at least 100 answers in here.
Wow.
I really appreciate everyone sharing those. All right.
There is the skull. And you could see from the picture there are different parts. This is only showing a few of the parts. There are actually 22 bones. And the 22 bones will fuse or join together and they'll form the skull. Actually, they'll form two bones. They'll form the main skull bone and the jawbone, because the jawbone is movable. And so all of these bones that you see on that picture of the skull, they all fuse together. When you're a baby, though, up to, I think it's about 2 years, these bones are separate. They're separated. They're not all together. And then they fuse together. What happens is, it's very interesting. What happens is there's this stuff, the same thing your ears and your nose is made of. If you look at a skeleton like good old Mort here, he has no ears and he has no nose, because that's not a bone. And so there's this, what's separating these parts of your skull is this same material, collagen. And what happens is the collagen turns into bone, and then, so that's what changes the 22 bones that you have when you're born into 2. And of course, you're a lot bigger now than you were when you were born, because bones can grow. It's a good thing. Otherwise, everybody would be this big.
And then the camera couldn't see us because we would be down here.
So what happens is, at the end of the bone here, at the end of every bone, well, not the very end, but close to the end, right before there's a little bump here. Maybe I'll show it on this bone. Right here and right here are these places where the bone can grow. And so as you grow older, your bones grow. Now, I have a special question. Here's a tough question that I didn't know until I looked it up, but it's extra credit because some of you guys are really sharp. And so there's a bone that a baby doesn't have that we do.
I'm fully depending on you for this. I have no idea what the answer to this question is. Thanks, Marty.
You're welcome. There's a bone that adults have And when babies are born, it's not a bone, it's this collagen, this ear and nose material.
We have several people guessing teeth.
Teeth? No, teeth is a
Okay.
good guess, but
Okay.
teeth are not considered bones. There are 32 of them when you have them all and you're an adult, but they're not considered bones because they don't have marrow in the middle. That stuff that makes all the blood cells. Teeth don't have that. And teeth have different coverings on them compared to bones. But that was a good guess.
Good. We had several people guessing teeth. Thank you all. That was my guess too. Cleo, yes, thank you everyone. Isis. All right.
I'll give you a hint. It's below the waist.
Holly says kneecaps.
The kneecap. Ding, 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 ding.
Good job, Holly.
You guys are terrific. The kneecap is the science name for it, the fancy name for it is the patella. And so the kneecap or patella is just this spongy kind of material, but then as an adult grows, that turns into a bone. That's very good.
Yeah, looks like a bunch of other people also. As soon as I kept scrolling in the Q&A, I saw a bunch. Thank you, thank you to Coco and Gayatri and Nate.
Did they all have the patella?
Well, you know, now the knee.
So, the knee is great.
Yep.
I will count that.
Nate says patella. There we go.
Okay.
Oh, can you please spell the name of it? Yeah, Patella.
Right.
I'll write that out here.
It's like a combination of the names Pat and Ella.
Yep.
So that's the fancy name for the kneecap.
Yeah. Milo says it kind of sounds like Nutella.
It sounds like
it does.
But it's not as tasty.
That's right.
So let's see what else I want to talk about. Oh yeah, do we have that picture again of the?
Pulling it up.
Okay.
There we go.
So the interesting thing about this is these are some of the many bones, parts of the bones or section of bones that make up the skull. Remember, there are 22 of them. But the interesting thing is next week, when we talk about all about the body, we're going to talk about the brain. And the brain is, the parts of the brain are named after the different names of the parts of the skull. So you have the frontal section called the frontal lobe. You have the temporal lobe near your, no, temples, yeah, up here.
Oh, right, yeah, thank you.
Yeah, you have the occipital, which is the occipital lobe back there, and you have the parietal bone, which is over here. And we'll learn more about that and what these different parts of the brain do next week when we talk about all about the body, and we'll learn about the brain and that sort of thing.
Great.
Okay.
A couple questions here.
Sure.
Olivia, hi Olivia, welcome. She asks, part of a baby's head on the top is soft. Why is that?
Well, just think, you have a baby coming through a little narrow opening when it's born. So if its head was fully formed and all in one piece, like in a 2-year-old or an adult or like your head, it would be too big to fit through there and to fit through that birth canal. And so it's soft because it has to be flexible to squeeze through a pretty small opening. I hope that answered your question. It was a great question.
Yes, thank you. All right. And all right, Ellie, hi, welcome. Looks like we had a few people join us after we got going. So
after we got going.
If we go backwards and cover a little bit of what we talked about already, then we will do that for you guys.
Now you guys are real sharp, so I think you're going to get this next one. This next one is, what's the longest bone in your body? And what's the shortest bone in your body?
Okay.
Yes, I know you know.
Thanks,
Of course,
Mort.
you know.
Yeah. Lewis was asking about that word I had written there, patella. Yes, the patella is your kneecap. That's the fancy word for kneecap.
Right. And
Yep.
that's the only bone that an adult has that a baby doesn't.
Yeah.
Okay.
Okay. So Lewis is saying that the longest is the femur.
The femur. The femur is a fancy name of saying the thigh bone. That's the one that goes from your hip. Can you see it? From here all the
Yeah,
way
there we go.
down to where the knee is. Like that. This is the femur. What? Oh, it's uncomfortable? I'm
Thanks,
sorry.
Mort. All right. Mort has to stretch his muscles out.
Right.
Yep.
Limber up.
Limber up. All right. Kanan said leg. Yes, the femur is one of those bones in the leg there. All right. A number of people said backbone or spine, and that's a really
Well,
good guess.
but look, here is
Yes.
a model of part of the spine. And if you'll notice, each of these is a separate bone. And it's made, it has this cushiony space between it that'll help you, bend this way and bend that way and bend forward and bend back. Because if it was one solid bone, you'd always be stiff like this. You couldn't bend over like that or bend over like that or anything. So because these are these vertebrae, that's the fancy name, the vertebrae make up the backbone, and so they're individual bones. Okay, so I hope you can all see that. They have these, sometimes you don't want to, this is the back of the vertebrae, and this is the front.
Spiny.
Yes.
Yep. Okay. Moises. Hi, Moises. Says, so for longest femur and for shortest, the bone in your ear. Someone else a little bit further down said the ear bone. Shortest, but Lily says shortest bone is in your ear, but I don't know what it's called.
Okay.
Good. Wow. So many. Nate is saying the ear. Bunch of people saying ear.
Ear is correct. Ding, ding, ding. It
Good
is
job.
a little tiny bone in your ear called a stirrup. And the reason it's called a stirrup is because it looks like the part of the saddle that you put your foot in. It looks like a stirrup. And it's one of the three bones that are inside the ear, and that helps you see. So when you remember, a sound is a movement or vibration or going back and forth of something quickly. It could be, usually it's air, but it could be a solid like a table. If you put your head against a table and can you hear that?
Yep.
Yeah. So it's the movement.
Or water, when you're in water.
Or water, right?
Hear someone jump in.
That's how whales communicate, in water. And in any case, it's this vibration, and the vibration goes into your ear, into your eardrum, and now your eardrum vibrates. And your eardrum is right up against these three little bones, the anvil, the stirrup, and I forget the third one. The anvil, the stirrup, and the hammer. That's it. And these three bones, and they vibrate, and then your brain translates that vibration into sound. That itself is just so amazing.
That's really incredible.
I mean, when you think of what your body can do, it can translate this motion of the air into sound. It can translate light into something you can see and recognize, like a camera. It's there's an interesting thing now that we're mentioning the eye. You have a lens in your eye, and the lens, if you take a normal lens and you hold it up, now not a glasses type of lens, but a lens that's round on both sides, and you hold that up, you're looking at someone, they'll be upside down. So your eye has the same kind of lens. And when you get an image on the back of your eye, it's upside down. And that image goes to your brain, and the brain flips it right side up. If it didn't do that, we would all look like we're walking upside down.
It'd be a great April Fool's joke.
Yes, but I don't know how well it would help you survive.
No. Ahmed has a good question here.
Yes.
So he says that our friend in the back, the skeleton, has no ears.
That's correct.
Does that count as a bone?
The ears are not bones.
Right.
They are another kind of material. It doesn't have a nose either.
Right.
So the nose.
So we were talking about those small bones in the ear.
Ah, that's inside your skull. Right.
Yeah.
So the bones are inside your skull. They're not bones that are on the outside of the skull.
Okay.
All right.
And Olivia asks, why do we have ears and not just holes in the sides of our heads?
Good question.
Very good question.
So, did you ever see one of these old-fashioned phonographs, where somebody puts a record on and you have to crank it up, right? And there's a needle, and then there's this flat thing called a record, and it spins around and plays music, or it plays a song. Well, they have this piece that comes out of the phonograph that looks like.
So there's our table. You've got a record on it. Off to a bad start. The point is, there's like a funnel.
Right, like a funnel. And so that funnel is used to send the music out. Similarly, we have ears because they're sort of shaped like funnels, and they take any sound, especially the sound in front of us, and they funnel it or direct it into the ear. Sometimes you might have seen dogs who have these ears, and they can move, or animals, they can move their ears in different directions, depending on if they hear a sound from that direction. They can turn their ears around to hear the noise in that direction. Now, not all animals have that. Some animals, like if you have a Cocker Spaniel, they have ears that just sort of flop over. That doesn't really help. But some animals, like a Doberman or a German Shepherd or hunting dogs especially, have these ears that can, turn around, and if they hear a noise that way, they can sort of turn their ears in that direction to get any information, to funnel any information or sound into their ears.
Kind of like if you're trying to catch a ball, if you're trying to catch a baseball and you've got a glove, you've got a mitt on, it makes your hand bigger. It makes it easier to catch that thing that's coming towards you. Or if you're, you've got like a net that you can throw out and catch a fish in the water with the net because it's covering a wider area. You've got, instead of just this one little point here, I started drawing something there and it went horribly wrong, and I just had to erase it.
Okay.
Instead of just hearing the sound coming into this one little point right here, you get to hear the sound coming into this whole area.
Right.
And then that all gets sent down there. Now, obviously, you're not going to hear the sound you're not collecting all this sound from all this space right here, but you're at least catching this much, which is more than catching this much.
Right. It helps.
It helps
you hear.
Yep.
Okay. So now we're going to jump onto another chapter in this book, and we're going to talk about nerves. So, what are nerves and what do they do?
Okay.
That's our next question for you.
All
and then we'll talk more about nerves.
There's skeleton. All right. We are jumping, chapter 9?
Let's see.
All right.
Chapter...
There's a whole bunch in this book. We're only going to cover a few topics today.
Chapter 9 is the nervous system. Yes.
Okay. Let me see really quick here.
Oh, what page?
Yep.
There we go.
47.
47. I was 47 once.
All right. I was 47 twice. I was not. Nerves, nerves. There we go.
Chapter 9, the nervous
Marty.
system. So you have nerves. You see that picture? You have nerves all over your body. If you can feel something.
I felt that.
That's because there's a nerve right there that sends a signal through the nerve cells to your brain. Do we have a picture of a nerve cell?
We do.
We do.
We do.
So this is a simplified drawing of a nerve cell, so you can get an idea. That's not a nerve cell.
That's a
nerve cell. So you can get an idea of what it looks like. And so you could have one of these nerve cells here, and it could have a long arm and connect to one of these other little pieces that come off the nerve center, and that little circle in the middle of the nerve cell is just the nucleus. All cells, all body cells have a nucleus. And so these little finger-like parts that come out of the nerve cell so if you have a nerve cell here and a nerve cell here, and these parts can come close together, and then the signal could be sent from this nerve cell to this nerve cell. Bzz. So that's what those little finger-like parts of the nerve cell are. So here's an experiment you can do at home. Get a ruler, and you're going to have somebody put their hand on the table. Good. And now I'm going to hold this.
We can't see it, so I'm going to hold the hand up here so that we can.
Okay, so hold it about an inch apart. Your fingers about an inch apart.
Okay.
And
I promise I won't cheat.
I'm going to put this, I don't know about that. I'm going to put this right here.
Okay.
And then at some time, I'm going to drop the ruler. Let's see how quickly James's nerves first he has to see it. That goes to his brain. Then that goes all down his arm and tells his muscle to squeeze. Let's see how quickly he can do this. I'm just going to let it go. Whoa! He got it.
I caught it.
I bet you could do better if you try. So you want to try it again?
Let's try it again.
Yeah, last time you did better.
I did.
Okay, an inch apart, fingers about an inch apart. And I'm going to hold this up, and then I'm just going to drop it. Oh, much better.
That was better. I got it at 9 inches instead of right at the end at 12 inches.
So you could do this at home and test your reflexes and see how fast your nerves are signaling, and how sometimes I've seen people where they just miss it completely. They just hold it. Okay, I'm ready. And whoop, nope, it's gone.
Yep. So
let's see if you could catch the ruler before it goes through your fingers.
All right. Isha says I'm getting really good at drawing. Thank you. I'm trying.
Too nice.
I was watching the webinar that was happening yesterday that Becca was hosting, where she was talking about prehistoric art and cave paintings, and I was following along with that. She has another one coming this afternoon at 1:30 Oregon time. So I'm going to try to learn some more from that one as well.
Okay.
I hope you all are learning a lot from these webinars, because I sure am. I have watched all of them. I learn stuff every time. Even when I'm sitting here helping you learn more, I'm learning from Marty. Like, I learned what's the longest and shortest bone in the body today and other stuff.
Okay, and you learned that we have 206 bones in the body, but there's more at birth.
That's right.
And they fuse or join together.
Exactly.
Now, I wanted to show you this because this has to do with both the skeletal system and the nerve system. So if you have nerves in your feet and your legs, and so how do those nerve cells go all the way up to your brain to let you know something is happening? Well, they do it through this part, your spine, or this is called the nerves in your spine, or the spinal cord. And you can see this part is hollow, and this is where the nerves go, and the bones, there's bones around the nerves to protect it, because if not, every time you fell on your back, it would hurt like heck. So these nerves are protected by the bones in your spinal column and in your spine, and these nerves go right through the hollow space here. You could see it this way as well. And that's how information goes from the lower part of your body to the upper. And there are actually a couple of different kinds of nerves. There's a kind of nerve called a sensing nerve, which helps you feel things, whether it's pressure or pain or hot or cold. These are sensor nerves. And then there's nerves called motor nerves. So it's sort of like the sensor nerve is sending information up to your brain, and then your motor nerves are sending information to your muscles to move. So your muscles move because of these sensor nerves giving it a signal and telling it it has to move. Now, how fast do you think these nerves move in your body?
That's a good question. Well, you are sending in your answers to that question. I'm going to send you a few questions from our viewers.
Please.
All right. I had the questions, and now they're gone.
They're gone.
Oh, Oliver was asking about that drawing. What is that purple dot? Here we go.
The purple box.
No, the drawing right here.
That purple roundish dot is the nucleus. So all body cells have a nucleus that has information about the body and how more nerves can grow and more cells can grow. So that's the nucleus or center of the cell that has the DNA and all the information. DNA is this great big long word that stands for all the information in the genes.
Yeah.
So that's what's in there. And there are other things in the nucleus as well, but we're not going to go into that. That's okay. A whole nother
We could do a whole webinar on just that.
We could spend a whole week talking about that.
Anyway, it's the headquarters of the cell. It's got all the information that it needs.
Right.
Lorna asks, when you hit your elbow really hard and it tingles and hurts for some time after, is that a nerve reaction?
That is a nerve reaction. Mm-hmm. You're hitting it, and sometimes
this bone is protecting. Here, let me stop screen share.
This bone over here is what, when you hit it here, this starts to tingle. This bone is called the humerus, and that's why get it? That's why some people call it the funny bone, because it's humerus. It's the humerus. Mm-hmm. And then you have these two bones, the radius and ulna. And you know, this is similar to the leg bones. In the leg, you have a big, strong bone here and two little bones here. So, excuse me, Mort. So in the leg, you have the femur. That's the biggest bone in your body. Oh, and look, here's the patella that adults have that children don't, or the kneecap. And these two bones are the tibia and fibula, just like the radius and ulna in the forearm.
Thanks, Mort. Okay. Sasha asks, is there any part of your body that has no nerves?
Well, your hair, we talked about this the other day. Mm-hmm. Your hair is not living. It was living when it's in your scalp, but as soon as it comes out, it's not alive. Otherwise, it would hurt every time you got a haircut. Same thing with your nails. If you can cut something and it doesn't bleed, chances are it's not alive because you need blood cells. As a matter of fact, even your skin, there's nerve cells right under the skin, so you could feel even a little bit of pressure. But
that's really useful to be able to, even just a light touch, to be able to feel that.
Oh yeah, because these nerve cells feel the pressure. But okay, that's all I want to say about that. I don't want you trying something silly.
That's okay.
Boop. Okay.
Kanan asks, why do people's legs move up when the doctor hits their knee with the rubber hammer thing?
That is a reflex. So there is some nerves that are automatic, that automatically do something. For instance, if I take a flashlight and I shine it in your eyes, the pupil the hole in the eye is going to get small, because what the eye does, the eye is like a camera, and it lets, if there's not much light out, let's say it's dark, and your eye, it doesn't get this big, but just to show you, it gets bigger, the hole gets bigger in your eye to let more light in. And if it's a bright sunny day, the hole gets smaller to just let a little bit of light in, because that's all you need. And so that's an automatic response. You could try that, take a flashlight and have another person stand in front of you and look at you. And then you look at their eyes, and then you turn the flashlight on, and you'll see the pupil, the hole there, the little black in the center, gets smaller. It's really cool. So there are some reflexes like that that are automatic. Another one is with your arm. You can hit the right part of the arm, and the hand will come up. It takes a little practice, doctor.
There we go. Got
it.
Okay. All right. So let's get to some of these answers.
Sure.
People answering, how fast do the nerves move?
How fast do they move?
Or, how fast does the signal move?
Yes.
Nerve. Right. Katya says about light speed. Lewis says nanoseconds. Janessa says over 1 million miles per hour. I'm just going to read out a bunch of these answers here. Aubrey says 900 million. Milo says 150 miles an hour. Evan says 0.9 seconds. Jacob is thinking faster than the speed of light.
Wow.
Katya says about light speed. Oh boy, as I keep, there are so many responses. I thought I was going to read them all. I would be here.
No way.
I would be here for another long time. Okay, well.
Thank you for
Lorna
being.
says super duper fast.
Super. It does
that sounds
go
about
fast.
right. Yeah.
It does go fast, but it doesn't go as fast as the speed of light. And the only thing that can go as fast as the speed of light is light, and other parts, other things similar to light, which we'll talk about in a future video.
Yeah.
So it can't
Actually, first webinar tomorrow, me and Diego are going to be talking about space. And I'm so excited about that. And we're going to be talking about light speed. I'll see you guys there. It's going to be great. Yeah.
When I went to college, I thought of majoring in that. Yeah, as a matter of fact, my dad encouraged me. He said that I'd take up space.
Well, here you are teaching science to the world.
Right.
It's great.
Okay, so the answer is the fastest nerve you have in your body sends a signal to your body at about 250 miles an hour.
That's quick.
That is, I mean, nobody can run that. Cars don't go that fast. So that's really, really fast. And these are nerves that are mainly, like if you touch a hot stove, you don't go, I smell something. Oh my gosh, that's my hand. You know, you don't do that. It's, it's instantaneous. And so you touch it and it's, whoa, and that's one of these nerves that are attached from the brain to the muscle that move that fast at about 250 miles an hour. Incredibly fast. There are other nerves that go a lot slower. That'll take maybe 2 seconds for a signal to go from your lower body up to your brain, because it's not that important. It's sort of the express lane and the local. So the express lane is for real important stuff, like your hand is burning up, but
it's like urgent message.
Right. Answer me
You're
first.
burning your hand. Pick up my call. I'm calling you. It's important.
Right. And the other one is less important, and so it gets a lower.
I'll wait.
Yeah, I'll wait. Right.
It's okay. Yeah.
Okay.
Arjun has a question I wanted to answer.
Sure.
I'm sorry I didn't catch this when you asked it earlier. If you get burnt with a metal bar, will it ruin your bone?
Well, the answer is exactly.
Right, yeah.
It depends. So there are different types of burns. There's a burn just on the surface of the skin. That's called a first-degree burn. And there's a second-degree burn where the skin is burned and the area right below the skin, the living tissue. Remember, this stuff on the top is not living. You have a picture for me?
I'm going to make a picture.
You're going to make a
because
picture.
I am so good at drawing.
James is going to show us his artistic ability.
That is skin.
Skin.
And then there's layers under the skin. So I'm just going to draw kind of lines under the skin there.
Is there a bone under the skin eventually?
There's a bone.
Okay, good. So what happens is you could have just the top layer burned like that much. Right. Or you could have a second degree burn. Well, actually, the first degree is just on the top. It doesn't go
right. Yeah, it's just hitting that top.
And then a
there.
second degree burn goes down there, and that is very painful. And that
because in here, here we go. I'm going to use blue. Nerves.
Right. And so that's when it goes under the skin into the living tissue. A second degree burn has these blisters, will blister up. Can you show us a blister, James? Yeah, it's going to blister up. Now, when that happens, you don't pop the blister. The hand will heal by itself if you cover it and protect it. But that is a very painful burn.
Very.
And then there's a third degree burn, which can go all the way down, maybe up to the bone. And what happens is that's not as painful as a second degree burn. Could you guess why? Why do you suppose a third degree burn is not as painful as a second degree burn?
I'm just going to answer Cleo's question here really quick. How many layers of skin do we have? I was just drawing lines there to show getting deeper and deeper into the body. It's not that we have like a billion layers of skin there.
Well, you have the skin called the epidermis, and then there's the dermis, and there are fat layers and muscle layers, and then the bone is on the inside.
Lorna says third degree burns hurt the least because it destroys the nerves.
You guys are sharp.
But it is the worst because it burns through all the layers of the skin.
That
you got
is
it.
Correct.
If there's no one there to report, like let's say you have people posted at the edge of your camps to say like, hey, there's an enemy coming. If those people get captured or taken out and they can't report back that the enemy's coming, you get no report that the enemy's coming. That's your nerves getting burnt and killed. Wow, so many people. Okay, yes. To the 1 billion of you that answered because it destroys the nerves, you are all absolutely correct.
Okay.
So Arjun asking if you get burnt with a hot piece of metal, hot piece of anything, if it goes that deep, that bad, then yes, it could damage the bone. The amazing thing about your body, there's so many impressive things about the body.
It's true.
It can send signals at 250 miles an hour. You can do all this stuff. You can catch a ruler. The most impressive thing to me is that like the whole thing fixes itself. Just about anything you can do to it.
Yeah. It's important that you
It's
feed it properly,
repairing.
but it'll repair itself.
My car doesn't do that.
No, it doesn't. There are about 7 trillion nerves in your body. 7 trillion. James is going to show you how many zeros that is. That's 1,000. That's million. That's billion. That's trillion. There are 4 sets of 3s. 4 sets of 3 zeros. And a smiley face. That's how many nerves. Is that incredible?
Yes.
And these nerves grow when your body grows. They have to. Otherwise, there would be parts of your body that you can't get feeling from. Now, what's the longest nerve in your body?
We're going to end off with this question here. I'm going to take some responses. We've got about a minute left here. So we're going to let you send in your answers to what is the longest nerve in the body?
Where, and you don't have to have the name of it, just where do you think it's located?
The pinky. I think.
Not even close.
All right. Well, let's see. Bunch of people saying the spine.
The spine.
There
Well,
you
the
go.
spine has these nerves, and
Yep.
you can see them there. As a matter of fact, sometimes what happens is if you stretch wrongly, these things can squeeze. I don't know if you can see that, can squeeze on the nerve, and that really hurts, and you'll like jump, and hopefully the nerves will fit back together.
Mm-hmm.
But this is used to protect it. But the spine is a good guess, but it's not, there's something that's longer.
Okay, we've had a few people guess the sciatic nerve.
The sciatic nerve, yes, the sciatic nerve is correct. Remember how the femur is the biggest bone in your body. The sciatic nerve starts here in the hip area, and then it goes all the way down. Actually, it goes through here and down the back and down toward your heel. Sciatic nerve, you guys are great. I appreciate your watching and visiting with us. And I hope you have a great day. Hope you enjoyed this video seminar. And remember, curiosity is the cure for boredom. So stay curious about how the world works. That's really what science is. Thank you, James.
Thank you, Marty, the least bored guy I have ever met.
And we'll see you next time.
Yes, us definitely will. Before we go here, so this book that we were teaching out of today, All About the Body, this is available at heronbooks.com. Any book on there. There's several courses available for free right now.
Like this one.
Like
this is available for free. You can get this for free and read about it and download it and read about all the different body systems for Zippo.
Exactly. Everything else on there that's not free, you can get 30% off of all of it with that promo code Delphian30. Thank you, everyone.
Have a great day. Bye now.